Literally, the cafeteria is across the hallway from where the Merlin engines for the Falcon 9 are being made.
Hey everybody, and welcome back to the Kodiak Shack podcast. I'm your host Vader, and we've got Bender here. And today we're talking with Cowboy, which Bender and I met Cowboy a long time ago, and he's moved on from flying jets, and now he's working at Starlink at SpaceX, I guess, technically, right? And so he was an F-16 pilot. He was at Osan, and then I believe he went to Shaw. And then after that, he transitioned out of the military and has now been working on some really cool projects over at Facebook previously, and then now at SpaceX. So Cowboy, thanks for being here. Tell us about yourself. It's not a trap.
Yeah, absolutely. Not a trap. You sure about that?
Might be a trap.
Yeah.
Might be a trap. All right. Yeah. So thanks for the intro. You got everything right there. Pretty much nailed it. But I think kind of the overall theme here is like I wanted to be an astronaut as long as I can remember. Like ever since I was a kid, my goal was like get an engineering degree, like become a pilot somehow, and then become an astronaut, and like sort of figure it out along the way. I think like by the time I was 8 years old, I could like go to any airport and be like, that's a 737, and like that's an A320 or whatever. So like aviation's like been in my blood kind of like forever. So I did my undergrad and master's at Cornell University, did in aerospace engineering. And I wasn't sure if I wanted to like join the military at that point. I like heard about ROTC, didn't know if that's exactly what I wanted to do. But I went over there and was like, hey, interested in being a pilot. What's the chance I can be a pilot kind of thing? And they're like, hey, we actually have a pretty good acceptance rate. If you do really well, like you can become a pilot in the Air Force. Still wasn't sure about it, but then my dad was actually like, do you want to design planes for the rest of your life, or do you want to like fly planes? I was like, yeah, obviously I want to fly planes. Like that sounds awesome. And he's like, well, if you want to fly planes, you should fly the coolest, fastest kind of thing out there, which is obviously fighters, right? So maybe you should think about this military thing. So I did, signed up for ROTC, got a scholarship and did pretty well and ended up getting accepted to go to NJET. Went to Shepherd, did decently well at Shepherd, got selected to fly the Muggy Viper, ended up going to Luke. And Luke was an interesting story. My class was the first class to fly an all solo syllabus. So I actually did my dollar ride in the F-16 solo because they had some issues with the D models.
Nice.
And my class was actually the last 308th class to fly the Viper, so they shut down the 308th after I graduated. Now it's a 35 B course. Went to Osan, was at Osan for a year and a half. Awesome assignment, especially as a brand new lieutenant, brand new wingman in the jet. Tons of buffoonery, tons of fun times there. And then I was there for a year and a half, went to Shaw, went to the Tigers. And shortly after showing up at Shaw, I actually had some medical issues. Was deniffed about 3 months after showing up or so. It was a huge bummer because the squadron actually went to Archer right after I went to diff, which sucked.
Yeah.
Because I would have liked to shoot some missiles. But unfortunately, like continued to stay to NIF, was fighting some medical stuff for a while. After the 1 year mark of staying to NIF, the Air Force was basically like, look, you're probably not going to fly again in the Air Force. Do you want to stay in and finish out the rest of your commitment, post-pilot training? And we'll like reclass you as like an engineer or something like that. Or do you want to start kind of going through like a separation proceeding at this point? And I was like, yeah, if I can't fly in the Air Force, like I'd rather like continue to contribute on that side. So it took almost a year to do all the paperwork involved with getting like a medical separation from the Air Force. And in that time, I had a lot of time to think about like what I wanted to do next after I got out. My wife had actually been working as a UX designer for a number of years, freelancing while we were at Osan, and then she was working at an insurance company in Colombia. And so she would have loved to move to San Francisco, and I thought a career in tech would be kind of interesting for me. Like it's not aerospace engineering, but it's like some kind of engineering. So I ended up actually pursuing data science. So kind of did some self-teaching along the way while I was the NIF. And ended up getting a job in San Francisco at a carpooling company called Scoop as a data scientist. Was at Scoop for about a year before the 2020 and COVID happened and everybody stopped carpooling. Weird. So their revenue dropped off a cliff in March of 2020. Stuck around for another 6 or 7 months, but eventually moved on to Oculus, Facebook, what was called Facebook Reality Labs at the time, and now it's just called Meta. And I joined a computer vision team that was actually working on hand tracking and object tracking. And there's cameras on the outside of the headset can kind of like see the world around you. You can track your hands, can track other objects, and I was a data scientist on that feature. Yeah, but ultimately, like, wasn't super excited about the product. Like overall, had some like cultural issues with the company. Great company to work for, like in a lot of ways, but just wasn't a great fit for me. So I ended up leaving this summer and got a job at SpaceX, working in Starlink special programs as sort of a technical program manager kind of a role. And just started there about 3 months ago. So that's where I'm at now.
We here at the Kodiak Shack podcast would like to welcome our new sponsor, Adamus Cyber. Working with the military means there are some minimum cybersecurity requirements that are in every contract. Complying with these requirements can be painfully slow and really take your company's focus off your military customers and end users. Thankfully, the team at Adamus has simplified the process exclusively for small businesses working with the military. It should be expected that security requirements are going to be a part of working with the military, but they don't have to be difficult. Learn why prior guests on the podcast like Arun from OpsLab or Brian from ResCon use Adamus to comply with the NIST 800-171, DFARS 7012, CMMC cybersecurity requirements in their contracts. Check out their website at www.adamuscyber.com and tell them you heard about them from the Kodiak Shack podcast. Their website will be in the show notes. We appreciate all the companies that want to work with the military, and we understand working with the government isn't always the easiest thing, but we appreciate companies like Adamus that make it just a little bit easier. Nice. Well, so a lot of things I got to bring up here. We're gonna rewind. So for everybody who doesn't know, Cowboy went to Shepherd, which is called NJEPT, which I'm not going to even attempt the acronym, but effectively, people who go to NJEPT are normally the big brains. So guys like me, the caveman in the fighter community, go to Columbus or one of the other bases, and then normally the guys who are get good grades and good academic guys end up going to NJEPT. So that's good that you got to go there. And then as being an Office fan, the TV show, how do you feel about Andy Bernard having gone to Cornell?
He actually, I think he came to Cornell and did like stand up, and somebody on the like events team or whatever at Cornell that like brought him there gave him like a Cornell bear, like with a little mascot on it. And apparently it actually made it onto the show the next season. And like that bear was like sitting on the desk. I haven't like seen a lot of episodes of The Office. I'm not like a huge fan, but that is the one thing that keeps.
Yeah, no, it's definitely a thing because I think I've watched the entire series like 4 or 5 times. You know, that's a lot of TV watching. But yeah, they've almost become synonymous.
That's why Cowboy went to NJEPT.
That's right. Yeah, he was reading books and getting his master's while I was watching The Office.
Yeah, exactly.
Well, great. So that was kind of your background in it. And for the Kodiak Shack podcast, obviously, you know, we talk about innovation and specifically for defense. And you have a great perspective, and I want to get your input on this because we've talked about VR, we talked about AR, we've talked about augmented reality, but the mixed reality. And so now when we're talking about the eye tracking, right? Or not the eye tracking, but tracking your hands in different objects like that, from kind of a fighter pilot's perspective, because normally the person explaining the VR, the AR, the XR is not a pilot. They're just a engineer, but you have a great insight in where do you see that utility specifically for like VR training, AR training, XR training for the future pilots?
Yeah, I think there's 2 big areas that I see it working really well. For one thing, it's all about the reps, right? Like everything in pilot training comes down to like how many reps can you get, and with the flying syllabus that you have, you know, there's only so many times that you can get a jet, you know, the student and then an instructor to like go out there and like get a rep to go see something. But if you can give a dude a $200, $300 headset and stick him in a dorm room and just have him repeat the roll into the wire or whatever it is, like 100 times in his dorm room. That is so much better than chair flying. Like we did the thing where we like had the poster of like all the switches and stuff on the wall, right? And you're like, okay, this is kind of dumb. Like I kind of get the flow of like, here's where this switch is going to be, but like, dude, if you throw on a VR headset and can be sitting in your dorm room, actually flipping switches in the cockpit and get a feel for like, this is where this switches is, and like, this is how long it's going to take to get the engine to like, whatever it is, 20% or like, before you like add fuel. This is how long, JFIS Start 2 is going to take. And you just get it's not just the, left hand, right hand of it. It's all of it. It's the sound, it's the timing. And then the first time you actually go into the jet to do it for real, like you've done it 100, 200 times before. I completely agree. You're never going to replace the G's. You're never going to replace the feeling of like being in that BFM turn and like cranking your cranium over and like looking for the other dude. Like you're not going to be able to replicate that 100%. But if you can get 60, 70, 80% close to that by like, hey, I'm sitting in my chair and I'm like, that's where the dude is over there, and like, that's where I need to be looking. It doesn't translate 1-to-1 to the jet, but the more reps you can get, the better it's gonna be in the end game. Jets are expensive. I mean, the F-16 is like what, $20K an hour or something like that, right? Like that's a lot of VR headsets.
Well, I've told the story before, but I'll kind of, as a anecdotal point, like, so we were screwing with some VR trainer at Holloman before I left. And so I like threw that on and I was flying around in DCS just as like a demo. And I get airborne and I go to reach for the landing gear, which is my habit pattern, obviously. And I'm like, ooh, VR, I can't just grab the handle and drop the gear or raise the gear. So is that something that you expect to be either with gloves or some sort of pass through that we're going to be able to do in the near future or currently doing?
Oh, 100%. Yeah. With the Oculus headsets, the Quest 2s and the Quest Pros. So there are cameras on the outside of the headset that can track where your hands are in space. And so it works decently well. The tracking actually works quite well. What's actually quite difficult right now is the developer interaction and being able to say like, hey, here's where your hand is relative to a switch or to like an object in the game or in the VR environment. And like when you're picking up a block, like understanding, hey, like I'm holding on this thing or I'm not, like I've let it go. That's the part that I've actually seen the most trouble with, of like, hey, if I reach over like to like raise the landing gear handle, getting the software to understand exactly where your hand is relative to the handle can be a little bit difficult. But the precision of like where your hands are is actually pretty damn good. I've seen demos of people playing like Beat Saber, which is like, I don't know if you've seen that, but it's this game. You've got like lightsabers, and it's almost like Guitar Hero, but you've got lightsabers and you're like hitting blocks like on a rhythm. It's like one of those rhythm games. And you've got normally you're using controllers to like hit these things, and you're moving your hands pretty fast because you're like, you're kind of all over the place. I've seen demos where you're like not even using the controllers, and the headset is just tracking your hands in 3-dimensional space, and you're like just as accurate as using the controllers that have all the accelerometers and stuff built in. Like the tech is really good, and it's just kind of a matter of getting the last little bit in place of like understanding where your hand is in the virtual environment and doing the interaction piece. That's quite difficult.
Well, and that's where, so the non-tech savvy guy, I was a geography major because it was easy. And so
Nice.
they're like, hey, figure out VR. And I don't know what they're called. It's kind of the cone with the handle, it's kind of got the circle on it where I call it an ice cream scoop, but you kind of aim it where you want and you squeeze the trigger to like click on stuff.
Oh yeah. Yeah. The laser pointer.
Exactly.
Yeah.
And I was like, there has to be a better way, and now it seems like
totally
that is reality. Now maybe this question
totally
doesn't make sense. But obviously in VR, you kind of perceive it as like a 3-dimensional space. You're sitting in a cockpit. I can see things are more near, and the ground is much farther, obviously. But does a computer understand it in the same way that I perceive it. Like my hand is next to the gear handle versus next to the terrain just up and left of my hand. Like the computer knows those relationships.
Yeah, so it's building like a three-dimensional space essentially in the world, and like the way that it actually works is there is a three-dimensional model that you're like essentially flying through, and the computer is doing a lot of really complex math to basically project that like what you're seeing onto your two eyes like in the correct distance so that it is what we call stereoscopic, or like it looks three-dimensional to you. So it takes the three-dimensional view and then projects it onto two-dimensional planes that are the right, like an eye length apart, so that it looks three-dimensional.
That's pretty cool. And it makes sense, you have fidelity, you look at something far away and you're like, it's a little blurry, just like it should be. And then you're close up on your instruments and you can read the dials and the numbers. So, I mean, it is impressive, and I can only imagine at the speed how things are changing. It's only going to get better and better over the coming years and decades.
Yeah. Actually, so one of the cool things I got to do when I was at Meta is they do a like a demo day of like the research lab, and I got to try out all of these cool headsets. Essentially, what they did was they're like, we know that there's all these issues with VR headsets, right? Like the resolution isn't great, the field of view isn't great, the brightness might not necessarily be super great, the processing power on the headset isn't super great. And so what they did is they took all of these different problem areas and they made a headset, like a custom one-off headset. These things are like, $20,000 a piece or whatever. And it was like an engineering prototype to solve that one particular problem. So like they're like, let's forget about spatial resolution. Let's just look at field of view and make the widest field of view headset possible. And literally what they did is they took like 4 lenses from a regular Oculus headset and like literally like super glued them together. It's a little more complicated than that, obviously, but like essentially had, the like wide field of view night vision goggles, the like ones with the 4 barrels or whatever. It kind of looked like that, and like a super wide headset. And then they throw you in the VR environment. And you're like, this is what we could get if we had this super wide field of view that went all the way out to like 160 degrees, whatever. They had another one where they like had a really narrow screen, so it wasn't a super wide field of view, but the resolution was insane. Like 8K, this of like pixels like this big or something ridiculous like that. And they actually had this slider in the game where you could simulate lower resolution headsets. So it was like Quest 1, Quest 2, Quest Pro, which is the one that just came out. And then it was like this headset was like way up here. And they literally had an eye chart in the corner that was like, here is what, like a doctor's eye chart would look like if you had 8K vision. And I was like reading a book in VR, like with no eye strain. Like it was so clear that like in that little window, like the field of view wasn't very big, but the resolution, practically looked like real life. It was really impressive. So it'll get there. We have the technology to be able to solve a lot of the problems with VR right now. The problem is just like the engineering constraints, like fitting all of these solutions onto a headset that's actually comfortable to wear, and then like power, thermals, like these things are really hot, and just like the compute power as well, because you got to remember a lot of these are mobile headsets, like they're not plugged into a desktop computer, and so it's essentially like a cut down iPhone that's running a lot of this processing power. And when you try to run like 8K per eye on like a super wide field of view, like that's a difficult engineering problem to solve.
Well, and it's a great approach to solve the problem, rather than saying like solve this resolution issue inside of the current constraints. It's just like solve the problem, and then we will figure out how to put it into the current constraints.
Exactly. And it also gives you like a window into the future of like, here's what it could be. And it gets people really excited about it and like bought into the idea of like, this is a problem I want to go solve because I can see how awesome this will be if I go solve the problem.
Well, and it's a excellent idea to put them side by side, stack up the quality of others, the acuity right next to the one, it's like buying a TV if you're just looking at
Yeah,
like three
exactly.
different houses, you're like, I don't know, maybe they're the same, maybe it has better resolution, but you go to the store and they're all stacked up next to each other, and like that is a good image right there.
Yeah, yeah. Some of this was actually for like leadership demos, for like the engineering leadership to be like, which problem do we want to solve first, or like which like where do you want to have the most money to go into solving some of these problems.
So
That was another
So
use case
two
of that.
questions for your time at Facebook. So obviously you're in
Mhm.
the fighter community. You got to enjoy all the benefits and downsides, honestly, about being in the fighter community. We talked offline about, weather days and having to go out there when you know full well that you're just going to come back inside after wasting an hour of your time. And, and you may have been in the same spot. You're a military member and you think like, man, private sector doesn't do this kind of stuff. The private sector gets it, and it's easy to do the grass is always greener. So obviously you were at Facebook, and I'm not asking you to bash anybody, but what was the community like as compared to the fighter community that you knew? And then what was it like, was the grass greener, relative to your experiences?
Yeah, it's a great question. It's something I thought about a lot. In terms of the community, that was ironically for a social media company. That was actually one of the things that I had the most frustrations with. Maybe because my team is like really engineering heavy, but I felt like socially it was difficult. Granted, this was a year and a half into COVID, and like a lot of people were working from home. But I would go into the office pretty much every day, and I was like the only person in the office, and like I didn't really have a good social group of coworkers. I'd literally go in the office every day and like sit on Zoom meetings in a conference room by myself because everybody else was working from home. And I don't know if that was like a reflection of like my specific team that was like super engineering heavy, like research heavy, or like Facebook in general, or just like a sign of the times. Because I feel like a lot of the folks that had been there for a lot longer than I had, like pre-COVID, had a lot of really good social groups that they were able to keep in touch with through instant messaging, like our internal messaging tools and things like that. But if you didn't already have those relationships, it was really difficult to form new ones. So I'm sure a lot of that was just like the situation. But certainly like my situation was I felt socially not super connected with people really well. And then as far as is the grass green on your side? The way that I put it to people is like my time in the military, probably some of the like best, most rewarding, like incredible experiences I will ever get to have in my life. And also probably some of the crappiest, like, man, this sucks. Like the range is really high, right? Civilian life, that range is a lot smaller. Like it's a lot more in the middle. So like my best days are pretty damn good. My worst days are not that bad. It's kind of somewhere in the middle. They're like the employee, like the perks of working at a big tech company like Facebook are like kind of insane. Like if you watch like Silicon Valley, it's like it feels like you're walking into an episode of Silicon Valley like every day. Like there's 3 free meals a day and like multiple chefs like cooking like buffet. Like we had like smoked salmon in the morning for breakfast, like a full on salad bar, like every snacko's dream, right? My work-life balance was like really good. I could work basically whatever hours I wanted to as long as my stuff was getting done. I could work from whatever. Like, oh, you want to go like hang out in like Whistler for a week to go skiing and like work on your laptop, in between runs? Like, sure, you can do that. I have taken a call from a ski lift before. Like, absolutely. On the other hand, like, it wasn't nearly as meaningful as anything that I did in the Air Force. Like, I remember, I'll never forget this day. There's some flight that I had at on. I can't remember exactly what the flight was, but like we were doing probably some North Korea scenario or whatever. Like it went pretty well. Like everyone like shot their missiles, like dropped their bombs on target. Like it was like we did the fighter pilot thing, and it felt awesome. And I remember walking out of the squadron, and it was like sunset, and like second go was like starting up, and it was like dead quiet on the ramp. and then like one jet turns on and another jet turns on, and like the sun starts going down, and you're like, this is exactly where I want to be. Like, this is awesome. Like, I am doing fighter pilot stuff in a place that needs fighter pilots, and like the mission is right there. Like, North Korea is 36 miles that way, and we are literally ready to go tonight. And I don't think there's anything in the civilian world that can replicate that feeling.
Yeah, no, I appreciate that. And I think for everybody who hasn't had the opportunity to be exposed to the fighter community as much, like, you travel a lot, you work a lot, and, I think there's probably some like psychological explanation where like when the lows are low, those highs don't even have to be as high, but man, they sure feel pretty high, just because the disparity between the two, that delta. But in a fighter squadron, you go wherever. You could go to deploy in the desert. You could go to Malaysia. You could, wherever you go, 30 of your friends are coming with you. You have like, it's just all your friends, and sadly that is not common really outside the fighter community. Like heavies show up with 3, 5, 6 friends, and in non-ops side officers, it's the commander, the captain or lieutenant, and then like a sea of enlisted, people that they don't really hang out with as much because they're technically their supervisor, where a fighter squadron is just like 30 bros, you're probably within like 3 to 5 years of each other in your time in the Air Force. So it's sad that you kind of didn't get that experience. And it sounds like it may be, like you said, just kind of that time that you kind of got there, and it may not have been as, as true to what previously was experienced. One other question. Oh, go ahead.
The flip side of that is like in the military, you do move like all the time. And like, I think my wife and I were talking about this the other day. Like, I think since college, we haven't lived in one place for more than 2 years. And like we bought this house this summer. You can see like there's still like posters like we haven't like put up on the wall and boxes and stuff out there. And and part of it honestly is like this feeling of like, oh God, we're going to move in like a year and a half, right? Like, why even bother taking stuff out of boxes, because we're just going to move again. And we're like, no, like we're going to be here for a while.
Which is great that you get to do that. I mean, we had.
Yeah, but breaking out of the mentality is actually
and you're like, right now you're, or people looking to buy a house, and it's like, oh gosh, well, in 3 years, and it's like, this is your house. This isn't a short-term investment. This is like military, it's hard to see it as anything, but we went, Japan, and we came back to the States in South Carolina, because I was at McIntyre after Japan, so we were right down the road probably. But we had turns out we didn't even know this last move, our fourth move, we still not had broke the tape that taped it to leave Japan. And sure enough, it was a microwave that we haven't used in like 7 years. It's like, we probably don't need that anymore.
Nice. Yeah, the different color like moving stickers, right? Like the inventory numbers that are like still all over everything.
Same thing when you're moving not with the military, or is that different?
That's an interesting story, actually. When we moved from San Francisco to Seattle, we just hired kind of whoever, right? Like just some local moving company, and they showed up and just started like throwing stuff into boxes, like hauling it out. And we're like, where's the inventory sheet? Like stickers and stuff, right? And they're like, oh yeah, we don't do that. We just like take a video walkthrough of your place, and like we'll figure it out on the back end. And we're like, what? And like sure enough, like they broke a bunch of stuff, like standard stuff, right? But like, dude, moving is expensive if the military is not paying for it, and when you're not paying like full coverage insurance or whatever it is, like they'll break a bunch of your stuff and they're not going to care. So that was that lesson.
Yeah, well, that's good to know. Because everybody bags on like, oh, the military, moving me, but it sounds like at least if nothing else, it's been tested a lot.
Yeah, exactly.
The one other thing I was going to ask about working at Facebook and maybe at SpaceX, you kind of experienced something similar. But my understanding is, in the military, everything is like fill up all the white space. Like my day should be completely full of activities. And what I've been told, again, please correct me, is that there's actually a lot of times where there's like intentional white space for just kind of thinking and, working through problem sets where you can actually try to innovate and come up with new ideas rather than just filling your entire day.
Yeah, it really depends on your role. So like if you're a manager, your day is probably going to be like filled with meetings. If you're some sort of like technical lead where you're like coordinating a whole bunch of different efforts, you're probably going to be like talking with people and like making sure that communication is like flowing properly. But if you're what's called an IC, an individual contributor, which is like the programmer, right? Like the engineer, like the guy that's like the guy or gal that's like actually like doing the thing, not like communicating the thing out and doing the coordination, but like actually doing the design work, the engineering work, the programming work, whatever it is. Um, your calendar is full of a lot of white space to like just get your work done. Um, and part of it is like you do need to be a little bit productive and like push back on things. Like I get invited to like tons of meetings and tons of reviews that are very much optional. It's like it's more of like an FYI. It's like, hey, this meeting's happening. If this is relevant to you, you're welcome to attend and like listen in or whatever. But if it's not, like you're encouraged to protect your time and have time to like get your stuff done. And generally speaking, certainly at like major tech companies, nobody is tracking your hours. Nobody cares when you're working, as long as you're available for like weekly meetings, stand-ups, like that sort of thing, or like with the rest of your team. Outside of that, it's like work from whenever, work whenever you want. It's very much like we always talk in the fire community about like effects-based planning. It's like what do we want the end results, like end state to look like, and like let's work backwards from there to like figure out how we're going to get there. Very much the same mentality, honestly. They just use different words around it. It's just like deliver this end product, complete this ticket, don't like have this capability. I don't really care how you implement it. I don't care when you're implementing it. Like just go do the thing. And nobody's tracking your time. Nobody's tracking your hours, which is really, really nice. If you want to like go get a workout in the middle of the day, if you got a doctor's appointment in the middle of the day, like as long as you're not missing like some important meeting where you're like communicating information out or getting information like flowing back in that's going to affect your work, nobody cares.
Yeah, man, that's pretty nice. Because I feel like sometimes
it's really awesome.
I feel sometimes it's almost like either I feel the need I have to sit at work because if I'm not at work, I must be not good at my job, or other people feel they need to fill your workday up. It's like, well, you're here, why not get a couple meetings? And it's like, do we need a couple meetings? But
yeah, exactly.
Well, any parting shots on kind of VR, AR stuff that I missed before we move on to the SpaceX side of things?
I think one thing I was going to bring up and totally forgot was like the stuff that Red 6 is doing is really interesting, like the virtual like BFM target kind of thing. I haven't used the technology, right? So I can't speak to like first-hand experience, but my gut impression is that if you can figure out the ergonomics of it and not make it this like 10-pound thing that's cantilevered off your head and you're going to give everyone even more back problem than they already have. If you can figure out that part of it, I think it's a fantastic technology because, man, the first time I merged with an F-15, I was like, this thing is way bigger than a Viper and like does not move like a Viper at all. I got to BFM like Eurofighters, like F-35s, and a whole bunch of other like these dissimilar kind of adversaries. And man, the training that you get at fighting a dissimilar adversary is there's something that you just can't replicate with a Viper. Just the cues that you see, the way that a different airplane moves in the sky, so different than fighting even like a thrust limited or an AOA limited Viper or something like that. And so, yeah, I think that technology of being able to BFM somebody else that's not actually out there is super cool. Not to mention, like, man, the number of like single wingman instrument sorties that I flew in Korea, like I got the name Cowboy on a single ship instrument sortie as a wingman, trying to actually be tactical and trying to do stuff and failing miserably as a 69-hour wingman in Korea. And if I could actually go out there with like a VR headset and BFM somebody else and I didn't need to have an instructor in the other plane, and maybe like they could even come back and like just review my lines with me, right? Like they don't even have to fly a sortie. Like maybe an instructor can fly a sortie in the morning and then do like a quick 1 hour, 45-minute debrief with like another student that flew a single ship BFM sortie with an AR headset, and then just go review their lines with them and be like, hey, like look at that, and then bounce. Like that sounds like an awesome use of that wingman's time, right? And that instructor's time as well.
Well, and I agree. I mean, we've seen what Red 6 is working on, and you hear that, Red 6? We'd be happy to have you guys on. Anybody from the team? But yeah, I have so many questions. I mean, I think about it because right now we already have a JHMX, so a joint helmet mounted cueing system.
Yep.
So we already have a way that the jet provides us information looking out the window. If there's a way to splice into that, or I'm going to say non-scientific things, but a way to kind of interface with that. But my questions are like, where's the computing? Because it's not hosted on the jet, like you could have your iPhone in your pocket and probably do a better job computing it. But yeah, there's so many questions that I have where like, how does the simulation like maneuver? It's BFM. Like I make an error. Is it going to punish my error? Is it just this like grape that's out there? So yeah, I would love to talk with them because as an end user, there's so many variables that we probably think about in these with our background versus someone who's like, oh, cool. Yeah. Augmented reality flying around. It's like, oh man, there's so much more to it.
Actually I just thought of is Seed and like Sam's actually flying in the air. Like, can you imagine like doing a last ditch against a missile that's actually coming at you? I remember my patch at Luke, and he was like, we were talking about doing like, evasive maneuvers for SAMs. And he's like, you guys realize how quickly a missile is like an SA-2 is actually like flying at you? And he grabs a marker off the board and just like chucks it at a wingman, like that's sitting in the audience. Is like, that's about how fast it's moving. Like that's about how much time you've got to react to it. And I was like, oh yeah, okay, that's a good sense of like how quickly you gotta think about these things. To be able to look out the window and like actually see that telephone pole coming at you would be
well, and you think, not to get into any sort of, gray area here with classification, but you look out the window and now I need to pick it up a certain distance away to be able to do something actionable about it. Yep. It's like, am I even going to be able to like visibly see it? Like there's so many questions out there that, the sim is helpful with that, but a lot of the things, and not bagging on the sims, they're expensive sims. A lot of it is like generics. Like generically, it'll look like this, but it's not like this specific missile will do exactly that. Well, awesome. Well, so SpaceX. So Starlink, can you explain, because I'm not even going to try, what Starlink does to provide, like what is it specifically and what is it providing to people?
Yeah, absolutely. So Starlink is the largest satellite constellation that anyone's ever made. We currently have roughly 3,000 satellites orbiting in low Earth orbit. I think they're like 100 something miles up. And eventually the goal, I think, is to get to like 30,000 satellites orbiting up there. It's a lot of satellites. And the idea is that we're going to be able to, we currently can provide internet anywhere on the planet, like roughly 100 megabit per second, which is like it's slower than what you're going to get from cable internet or whatever, but it's a heck of a lot better than existing satellite internet at like 30 millisecond ish latencies. And the latency is a really important thing to do this kind of real time video, kind of communication. With a traditional satellite based internet that's out there right now, they are operating what's called geostationary orbit, which is at something like 25,000 miles up or something like that. And what that means is it takes radio waves almost a quarter second to go from you up to satellite and then back down to Earth again, like to do that relay. And a quarter second's a really long time to be able to try to do this like real time video, even like a phone call. When you're operating in low Earth orbit, you completely eliminate that latency problem. It is actually faster to take a signal on the ground, bounce it up to a Starlink satellite, communicate it over to another Starlink satellite, and then bounce it back down to the ground than it is to go through a fiber cable running on the ground. And the reason for that is because the speed of light in a vacuum is actually faster than the speed of light through a fiber optic cable.
That's wild.
And sorry, I got ahead of myself a little bit. The current generation of Starlink satellites, the way that they work is that there's a ground station. We've got hundreds. I forget exactly how many ground stations we have that have basically a fiber internet connection, and they send a signal up to a Starlink satellite, and then that Starlink satellite will then beam that signal around to an area on the ground. What that means, though, is that the satellite has to be able to see the ground station and the user on the ground. It's essentially like a bounce. We call it a bent pipe. There's lots of areas around the world where you're not going to be able to have a ground station in view. Think of the middle of the Pacific Ocean, right? You're not going to stick a ground station in the middle of the Pacific. And so what we've done is we've started putting what we call space lasers, literally lasers on our satellites that can communicate with each other. And they form a mesh network throughout the entire Starlink architecture, and allows satellites to talk to each other. And a satellite that is not in view of the ground station can now get a backhaul link through the laser connectivity down to a satellite that does see a ground station, and it can communicate through that network. And sorry, that was the part that I was getting to with, it's now faster over very long distances to actually communicate via the laser network in space than it is to communicate via fiber optic or copper cables on the ground, because the speed of light in the vacuum is actually faster than the speed of light through copper, through fiber. And so now, because of this laser network that we're slowly developing, it's not completely in place yet. And we're launching more and more satellites that have the lasers on them. We were able to provide internet anywhere on the planet. We have internet currently at like McMurdo Station in Antarctica. They can get 100 megabit per second, full on, like FaceTiming your relatives, on the South Pole. And hypothetically, we could, do cruise ships, airliners, like whatever else you can think of, literally anywhere on the planet.
That's amazing. I mean, it's all these, SpaceX and all these ideas that are, I guess postulated, and it's like, hey, we could do this, and then they become reality, and you're like, whew, this is some wild tech out there. And maybe I'm thinking of it incorrectly, because I assume it's just radio frequencies or it's radio waves. So really this is, it's not just internet. Like theoretically it could be maybe not cell phone, but some sort of variation on that. Like you can now communicate in any radio frequency as long as it can be transmitted across.
So interesting you said cell phones. SpaceX actually just signed a deal with T-Mobile to provide essentially basic connectivity services like anywhere in the world. So if you are middle of nowhere, Montana, there's no cell phone signal out there, you would be able to connect to a Starlink satellite, and probably not voice. I don't know what like the data rates are, but like probably like a text if you need to send like an emergency, like, hey, I am lost or whatever, that basic kind of cellular communication, and we're going to be able to provide that kind of I don't want to say internet service, but certainly some sort of communication services to existing cell phone handsets, because you're right, it is essentially just an RF antenna. Now the antennas of course are like really specialized to like certain frequencies, and we've optimized it to talk to the Starlink user terminals and not like a cell phone. And so there's some special stuff we got to do to like be able to talk to a cell phone. So you can't just like have it work with like, like a UHF radio or whatever. If they are operating on certain bands, but ultimately, yes, it's just RF.
And so another question, again, I'm way out of my depth. So I'm going to need your help here.
Yeah, no worries.
So now we're talking about, which this isn't new, but we talk about HF, which, has its benefits, and the VHF. And so very high frequencies, ultra high frequencies. So how does and I think this is the correct word, but the attenuation between like, hey, we're in space, now we're passing this information to the ground. Are there any like distance issues or weather issues or anything like that changes the ability for it to transmit, or the computers have to dope that out?
Yeah. I don't know. So my background is like not electrical stuff, electrical engineering and RF stuff, but my understanding is basically we picked frequency bands to communicate over that are not going to get attenuated by cool weather, rain, clouds, like that sort of stuff. Like it's transparent to water vapor, and it's like the right frequencies to be able to have the right bandwidth requirements and the right like look angles to be able to service like a spot on the ground. Definitely not an RF dude by any means, but certainly that's a lot of what the electrical engineers are doing, is like figuring out which frequencies to to use to like communicate with the user terminals, and the antennas and the user terminals and the gateway sites are all they all use like very specific frequencies and very like custom antennas to be able to like, make the whole thing work.
So how does it work when you're, so we've now got these satellites. You said how many is the like end state?
I think it's like 30,000. It's a lot. Yeah.
So now we have, what is that? And I don't know if you can talk about this or if this is proprietary, but what does that mesh or over the globe look like? Like, is this a kind of encompasses the entire globe? Like at all times there are satellites that are all parts of the globe?
I think that's the goal, is like anywhere on the planet is like you'll have a couple of satellites in view at all times.
So
to be able to service
so
that.
kind of like a GPS where, you know, like you're flying like a GPS aircraft and you're like, hey, I'm probably going to see 7-ish, 4 or 6 satellites at any one time, so I can then be able to navigate off of them or transfer information or anything like that.
Yeah, the difference between GPS and like what we're trying to do is GPS is in a much higher orbit, right? So like GPS is at like, I don't know, 6,000 or 8,000 miles up or something like that. Like it's not quite geo, but it's pretty far up there. And so because it's so much further up there, each satellite can see much more of the Earth at any given time. So I think there's only like 24 GPS satellites or something up there. Because we're so much lower to the ground, and because the antennas are like so much more focused onto a specific spot on the ground, we need a lot more satellites to be able to cover the whole planet. So that's why there's so many.
Yeah. And then, I mean, because again, geography major, but because they're so much lower, I mean, they've got to be cooking across the ground. Like they've got to be traveling rather fast to stay in that lower altitude orbit.
Oh yeah, absolutely. It's speed in space is a little bit complicated. So I am going to vastly oversimplify what's happening here. But essentially from any given spot on the ground, yeah, like essentially you're watching the satellite and it's like doing that. I don't know if you've ever seen like how quickly the International Space, again, I don't know if you've ever seen the International Space Station from the ground. Yeah, it's about that fast. Like it's in view for like a couple of minutes, right? And so I think one of the, again, not like an Earth engineer by any means, but I think one of the challenges is actually like the user terminal on the ground has to continuously like change which satellite it's talking to, like while you're on a FaceTime call, right? And like not have any hiccups as it's like changing which satellite it's talking to. So like the engineering that goes into that is pretty
well.
wild.
And that was kind of what I was thinking, is like, this is not like one Starlink satellite communicating with one ground station over a period of time. It's like bouncing from one to the next to the next. It'd be like I imagine it'd be like being in an airplane super low and your cell phone's just jumping from like cell phone tower to cell phone tower to cell phone tower as you rip across the ground.
Yeah. That's exactly like what the analogy would be. And the network guys are like just super smart and have figured out a way to be able to like make that work really seamlessly, which is kind of magic. I will say, so like one of the things I've always admired about SpaceX, and like I think when I was in college, like if I hadn't gone to ROTC, I probably would have gone to work for SpaceX like early in my career. Like I've always admired the company and kind of what they've done. One of the reasons for that is SpaceX kind of starts at the limits of physics and then works backwards to solve the engineering problems. It's like they take a first principles approach to everything. Like there's nothing inherently physically impossible about having 30,000 satellites providing internet anywhere on the world and like having an antenna that can like switch between satellites like really quickly. Like from a physics point of view, it's just RF, right? It's antennas, it's amplifiers, it's communication infrastructure. The engineering is insane. Like there's a lot of engineering challenges that go into that, but that's solvable. Like SpaceX goes like, let's take really smart dudes and guys and gals, solve the engineering problem. And they're not worried about like, let's go all the way up to physics. Like nothing is impossible unless, physics says it's impossible, which is something really, really that I like really admire about it. I think one of the, talking about innovation, one of the cool things that I've learned recently is Starship, which is their next generation rocket, like after Falcon 9. It's made out of steel, which is really weird. Like no one makes aerospace things out of steel. Like imagine making a Viper out of steel, right? Like it's aluminum and titanium. Like everything in aerospace is aluminum and titanium. Why? Because it's strength to weight ratio, right? Like you need things to be as light as possible and as strong as possible. So of course you're going to use aluminum and titanium where it makes the most sense. Turns out aluminum and titanium they're really hard to manufacture. Like welding titanium is insane. Titanium is also insanely expensive. Really, really amazing like thermal properties, strength properties, all that sort of stuff. That's hard to use it. It's also insanely expensive and it's insanely difficult to work with. Aluminum has really crappy like thermal characteristics. And for a spaceship that's like going up into space and re-entering the atmosphere like constantly, it's just not an ideal thing to work with. Steel has great thermal properties. It's really easy, like relatively easy to weld compared to other materials, and it's really freaking cheap, right? And one of the things that SpaceX really prides itself on is constant repetitions. We talked, earlier about pilot training. Pilot training is all about repetitions. Like flying a jet's all about repetition. Going into space is all about repetitions. Figuring out how to make satellites, like 30,000 satellites that can all communicate with each other and have these laser links that all talk to each other. It's all about repetitions. Having, that's the largest rocket ever built. It's all about repetitions. And so if you can optimize for manufacturability and cost per unit, then you can make 30,000 of something. Then you can make, like, you're not afraid to like launch and test a rocket and worry it's going to crash, because you're just going to make a new one in like a week. Like, not a big deal. It's relatively cheap. Like, they've stopped doing a lot of test flights recently, but for a while, like they were just like launching and crashing the Starship like prototypes all the time because it was such good test data. Like the best thing you can do is like launch it, see what happens, see what fails. It breaks, fix it, go launch it again. Like the best testing you can do, the best way to learn is just to go do the thing, right? And the only way you can do that is having something that's cheap and easy to manufacture. And that's what SpaceX like really prides itself on is getting those reps.
Yeah, and I got an opportunity to hear kind of Elon Musk talk at AFA. It was like a massive. It was cool. A room with thousands of people, so it's not like it was some special treat for me or anything. But his perspective, like you said, like if physics allows, then like we just need to find a solution. But one of the things is that he pretty much attempted to solve the thing that no one else tried before. They're like a Saturn V rocket, single use, just like whole lot of oomph, and then we'll just spend thousands and thousands of hours and millions of dollars building another, where it's now, like you said, like make it reproducible, make it able to be used multiple times, and now you solve so much of the consumption cost of trying to do all this stuff. So it's so impressive. It's amazing that stuff's happening out there.
There's a cool we call it the Elon algorithm. We actually sent out an email to the whole company like a couple of years ago, and it's sort of like become immortalized in like SpaceX history. Actually, when I walk into my office, like there's a big poster of the algorithm up on the wall, and it's this 5-step process that he uses whenever like he wants to like basically make a process better. The steps are I don't have this memorized. I've got this up on the screen next to me, but it's you start by making the requirements less dumb. So like a lot of times, like you'll look at something and you're like, why are we doing this? And sometimes people say like, oh, well, the blah, blah, blah department said we needed to do this. Departments don't make rules, like people make rules or like regulations or instructions or whatever. And so go find that person that wrote that thing and figure out like what their intent was. And half the time you're going to find that it's like the intent was miscommunicated when the step was actually written down. And they're like, oh, we don't actually need to do that. Like this is what the intent was. And it got misconstrued into this other thing, right? So like, figure out if your requirements are dumb to start with. Like, well, why are you doing the thing that you're doing? Try to delete the part or the process. So like after you've like kind of taken out all the dumb things, figure out like what's still necessary. Great example of this is like a lot of the things that we do at SpaceX when like we're building satellites, for example, we don't do it in the clean room. Like you always think about like the bunny suits, like the white things you gotta like go through the air shower or whatever to like remove all the particles. We've actually removed the entire clean room step because we build satellites so quickly that there isn't even time for contaminants to like get on the satellite. Like that's how fast we can build a satellite. It's like matter of like hours. It's wild how quickly the satellite actually works. Crazy. And so we're like, wait, why do we even have a clean room? Like we don't even do this anymore. So like try to figure out like why your requirements exist in the first place and deletes things that don't need to happen. One of the engineers I work with, he always says the best part is no part. If you can delete the thing entirely, great. Like design around it, make the process better by just taking things out. Then the third step is to simplify or optimize. So optimization, like the most common error is optimizing something that shouldn't exist in the first place. So once you've made your requirements less dumb and you've deleted all the non-necessary things, that's when you start to optimize, and you try to optimize for cost, mass, producibility, like manufacturability, like assembly, like whatever it is. Once you've then optimized your design, that's when you start to accelerate. That's when you start to get all the repetitions in. So you don't start to like speed up that production line and start to get all those repetitions until you've done those first three steps. And like now is when you should start going faster. And then the very last step is automation. It's important that automation happens after all of these things, because the human in the loop is gonna be able to actually like see a lot of things that a computer is not gonna be able to do for you. And it's only when it's like you're running up to the limits of like human ability that you start getting a computer in the loop, or like when computers are really, really great at like like staring at a piece of data, like waiting for an alarm kind of thing, like something like you try to get a human just like staring at a data stream and like looking for something, like that's something you want to automate, right? Or like the same thing over and over again, like trying to like reproduce some sort of like step in an assembly process. That's something that like a computer or an automated process is really good at. But you're not going to automate until you've done all of the other things in the process, and like doing all those things in order, like that's the Elon algorithm that I think the company is like one of the things that the company has really embodied at every step of the way, and part of the secret sauce of the company.
That's great. And I think when you kind of explained that, I was like, man, I think the Air Force would be like 10% of what it is today if they embodied this. Because I think, and it's apparent that it's obviously well thought out, because you look at it and when you explain it, it makes total sense. Like, hey, don't have a computer help you optimize or help you do something that doesn't even need to be there in the first place. Like if you bring in the computer too early, you're just going to optimize for things, like it already said, that shouldn't be there in the first place. That's great. And I think, again, like not trying to compare previous jobs with current job, but how do you like, obviously it hasn't been a long time, but how do you like being there and community and all that?
Yeah. So Elon is very like famously like very in the office mentality, which is I think kind of counter to like a lot of tech companies. What I always said when I was at Meta and sort of frustrated with the like no one was in the office was I think people are going to start self-selecting into communities and workplaces that have different levels of like social in the office kind of requirements. A lot of people at Facebook really liked the fact that they could work from home and just like code on their laptop all day, like sit and drink their coffee and like have their cats with them all the time and like never have to get out of their pajamas, right? And you never see another human. Like some people absolutely love that. I cannot do that. And at all of Elon's companies, he's very much about like being in the office really increases productivity. Whether or not you agree with that, like that's, whatever. I've seen a lot of cases where that's been really helpful, where I've overheard conversations about people talking about like some design that I was working on, like, oh, like this doesn't have this thing. And I was like, hey, are you talking about this thing? Like, actually, yes, it does. Like, here's a spec sheet, and like we'll quickly like go talk about it. And they like that was solved because I was in the office and like overheard that conversation. And just the camaraderie and like the environment, I personally really like going in the office every day. And the community has been a lot better for me personally. And this is like not a judgment call on Facebook or anything like that. It's just like SpaceX has been a much better fit for me personally than when I saw it at Facebook. So yeah, it's been really great. That the stuff that I work on is really inspiring. I just really love being back in aerospace and being around like hardware and rockets and satellites and stuff all day. Like when I get a chance, so I'm up in Seattle, the Starlink main office is up in Seattle, but I do get a chance to go down to the main SpaceX office in Hawthorne pretty often. Hawthorne is a neighborhood of LA. Um, and when you walk in there, like you see the like Dragon capsules that like the manned spacecraft capsule that we fly like up in the ceiling, like as soon as you walk in. You see like Raptor engines like being built, like you see the Falcon like rockets getting built like on the factory floor. Like literally the cafeteria is across the hallway from where the Merlin engines for the Falcon 9 are being made. Like there's a metal 3D printer like 10 feet away from like where you go get your lunch. And it's so cool like to like just be there and like see all the stuff. It's a really inspiring environment. Like everyone there is like super bought into the mission, and being around it is really awesome.
Yeah, you talking about that. I mean, everybody who's not watching on the video, like you could see Cowboy like light up. And I think one of the things that in Cowboy, I know you kind of saw this on the ops side. So I was going to be a flight commander, which in an ops squadron, a flight commander is not the biggest deal ever. So they're like, oh, you got to go to this like 1 week flight commander training course. And I was like, this is going to be a complete waste of my time. And it was about 99% a complete waste of my time, except for this one thing where they brought in a bunch of squadron commanders to talk to us younger military people who are going to start leading people. And they were talking about incentivizing. And I was the only fighter pilot in the room. So the ops side. And they're talking about how like, hey, do we give days off? How do we incentivize people to work harder? And the maintenance squadron commander points at me and he goes, he's talking to the room, but he's pointing at me. He goes, do you think he has a motivation problem? Like, do you think ops has a problem being motivated? And you don't. Like one, it's like you have a vested interest in being good at flying and landing airplanes. And then, but what he was saying is like being too far removed from the operations, you forget what your objective is. You forget what your goal is. So, and I think, like you say, like, hey, it's very much an at work mindset or perspective, is because you get those experiences and you don't even get to go, like, you don't even go to lunch without realizing the gravity of what you're working on. So I think it's funny. You're probably used to being at work more just because you were in the military, but then also like it helps you kind of see the broader picture, see the bigger thing than your cog in the big machine, which I dig because seeing jets and stuff is always cool, but I can only imagine what it's like walking around and be like, holy cow, look at this stuff.
Yeah, I think that's really important for any job is, I mean, unless you're at like a 10-person startup, you're going to be a cog in a bigger machine. And that's by design. People specialize into certain roles. Like, I think I'm pretty decent at engineering. I'm pretty crappy at finance. I don't know how any of that stuff works, right? Like contracts, sales, that's not my jam. Somebody else is. And I'm really glad that they're good at their job so that they can do their thing and I can do my thing. That's why we specialize. But it's easier. It's easy when you specialize to lose track of the bigger picture. So actually going back to the first company that I was at before when I left the Air Force, Scoop, the carpooling company, we had a requirement that once a quarter, you had to take a carpool to work. And we usually do it like a week. Is like, hey, sometime this week, you got to take at least one carpool. And to be able to see the end-to-end and use the application that we're developing end-to-end, understand how the scheduling flow works, what happens if somebody doesn't show up, how do you file a support ticket? Like all these little things that if you're focusing on this one feature, you might lose track of the bigger picture. The term in tech for this is called dog fooding. It's eating your own dog food, like what you're producing. That's kind of where that comes from, I guess. Like at Scoop, we really encourage people to dog food the app as much as possible and just try it out. At Facebook, it was actually quite interesting. Everyone that worked in the Reality Labs division got a free Oculus headset to work on, like you needed it for work. But surprisingly few people would actually go dog food some of the things that we were developing. And there was I remember there was one time where I went and used an application, a third-party application that used our object tracking software that we were developing, and they had this weird overlay interface thing that sort of superseded the built-in stuff that we had, and we're that's really weird. Why are they kind of reinventing the wheel and like making it confusing for the end user, because now there's like two different menus to like interact with this like one sort of like features, and it made it like all the way to like release, like to the end user, and like went out to the public in the state, and like nobody on my team caught it until I like logged in one day and I was like doing something else entirely in that app, like collecting data for something, and I was like, hey, does anybody know about this weird menu that like this application's using? And like nobody had seen it because nobody was like dog fooding their stuff. It was kind of weird, and like the project manager, the overall like kind of head person for this team was encouraging people to use it, to stay engaged, and like to stay motivated, and like for whatever reason people just weren't, and I think that led to a lot of like being a step removed from the end thing, and like not seeing the overall impact of what you're doing and understanding the product end to end. And like you said, yeah, like you walk into the Hawthorne factory, the SpaceX factory in LA, and you're like there's a rocket right there, there's a Dragon right there, like there's an engine like right there. Like that's what I'm doing, is I'm one little piece in this big machine, but like that thing can't go into space unless I'm doing my little part of it, and it's pretty awesome way to stay motivated.
Yeah, I agree. And I think, again, there's probably a little more transferability, I guess, between, flying jets and appreciating machines and now what you're doing. What would you say?
Yeah.
But I know we're getting long in the tooth, so I got one more question, then I'll let you go, I promise.
For sure.
So again, as an outsider, probably everybody in the audience doesn't know, we can assume what kind of the heaviest lift is when we're talking about putting 30,000 satellites into space. But from your perspective, what is the heaviest lift or the most difficult thing that it's like, man, that is a challenge to overcome?
That's a good question.
Hitting you with the brain busters. Sorry.
Yeah. No, it's a good question. I think the reason I'm having trouble answering that question actually is because we iterate so much on our satellites. Like we're not putting 30,000 of the same satellite into space. Because we're putting 30,000 satellites into space, we launch like 50-ish at a time, like to rocket. Like that's just how many we can fit into a Falcon. Every flight, every launch, we iterate and make something a little bit better, because we learn. It's all about those reps, right? We learn something on every launch, on every single satellite that we deploy, and everyone gets a little bit incrementally better. And so it's actually like not 30,000 satellites into space. It's like 30,000 different incremental versions. Now, we're not actually changing everything on every single build, but you kind of get what I'm saying, right? It's like we're incrementally making steps to solve each problem as we're hitting it. Actually, I think the biggest thing that we're running into right now is like just having enough lift capacity. And that's one of the reasons we're like making Starship, is like the more mass, the more volume that we can put into space per launch, the better the economics are going to be, and the faster, cheaper, better like we can get these things into space. And so it's really just about timeline and like iterating on those things. I remember actually one of my IFF instructors, I think, it was an F-15C dude, and he was like, I don't have 1,000 hours in Eagle. I have 1 hour 1,000 times. And that's kind of what we're doing at SpaceX, right? It's like we don't have a constellation of 30,000 satellites. We have 30,000 individual like things that we're making better every time we do it.
That's a great perspective. And I think it's universal too. Everybody should be striving to achieve and do everything better. I don't know a single fighter pilot who's had a perfect sortie, and I don't know.
Yeah,
I don't know if there is a perfect sortie, and I think, SpaceX and all the people there are doing exactly that. Like every piece of that puzzle is striving for that perfection. And as long as you keep trying, like it's probably not going to get worse,
Yeah, exactly.
Well, Cowboy, I appreciate you joining me on the show. It's been awesome, because I'll be honest with you, obviously I'm getting to chat with you as a bro, another fighter pilot, but I just, it's like a fictional thing. You talk to someone, you're like, oh, that person works at SpaceX. It's like, nobody actually works at SpaceX. Like, I don't know those people. So I appreciate you taking the time, because I know you're doing some amazing work out there. So thank you. I do appreciate it.
Yeah. Yeah, absolutely. Thanks, man. It's been great. Like flying fighters have been fantastic, and getting to know like folks like you and Bender and all the other brothers in the community has been awesome. And I'm really grateful that I've been able to stay in touch with everybody. Because I kind of felt like when that door closed on me, like through medical reasons, I was like, man, I cannot, I'm not a fighter pilot anymore. But like, you're never not going to be a fighter pilot. And being able to still stay connected with the community has been like really meaningful to me. So I appreciate you like reaching out, and it's been great.
Yeah, no, and you're always a fighter pilot. We all learned, we all went through the same, struggles and trials. So we appreciate. It's always good to see when fighter pilots go on to do some wild stuff like you're doing. So I appreciate it as the current guy trying to learn a new airplane. So well,
Yeah, absolutely.
Awesome. Thanks again, Cowboy. I'll talk to you later.
Yeah, absolutely. See you
Bye,
later.
everybody.